physics and Linux stuff. I actually went to Utah State in film and English, and through the lab got into computer stuff. I think actually I was a developer for FreeBSD when the first announcement, when Linus sent the announcement out saying he had this new kernel and people were talking about it. I think I started using Linux with Slackware 1.0. I bounced around a lot of different distros and played with a lot of different things. Through my career, I've probably been in almost every role in tech, from software developer, project manager. I've been a CEO for a company, done a couple startups, all sorts of different tech things. Right now I'm leading up technology, I'm leading up the infrastructure and security at a place called Divvy. We're kind of changing up how credit cards work. We're kind of the Dave Ramsey. It gives you control of the credit card before, so like you'll be able to pull up on your phone and authorize things before you swipe it. It's kind of cool. And I've also just released a few weeks ago this book. If anybody wants to flip through it, I can pass it around. But you've got fingers with grease on them, so feel free to look at it. It's about, if you've ever heard of design thinking or not, basically this book talks about the things I've learned as I've been through these different roles in the tech industry. And it talks about how to be kind of more successful in the tech and the kind of people challenges that are really unique to technology. And design thinking is a way of approaching problems that architects have used for quite a while. And it's about using design thinking to help address problems in technology. So just came out 2-3 weeks ago. So Docker and ephemeral systems. Let's dig into this. Actually, before I start, how many people have more than a passing experience with Docker? Cool, it's about half the people here. Okay. How many of you think you really, I want to ask the wrong question here. How many of you love the concept of ephemeral systems? If you really understand what it means and really get into it. Is that a less kind of, okay? All right. Let's see if the clicker is on the right direction here. There we go. And I am going to the right slide. Okay. So just kind of as a high-level overview of what containers are, I think a lot of people have challenges about this. When I was on Front Runner the other day, some developers were sitting on a chair behind me, and it was all I could do not to bite my tongue because they were going on and on about containers and how they don't need containers, and containers are just causing them problems. And it was very evident they didn't understand what a container was, because they're like, well, we can just use virtual machines and just on and on and on. So really quick comparison for those who don't know. A container is just a process. It's actually existed, the concept of a container has existed. Solaris was actually the first system that came up with this. All it is it's the ability to take a process, to partition that process down on how much memory and CPU it can use, to kind of box in its networking, and then one thing that's come about with Linux is they have this layering thing that's really made it valuable. And I'll get to the layering storage in a minute. So if you just compare these two things, think about running a new server. If you boot up a virtual machine, assume that you already have the stack running, maybe it's VMware or maybe it's bare metal. You're going to have to load a BIOS. The BIOS is going to have to dig up a bootloader somewhere. That bootloader is going to load an OS loader, which boots the kernel, runs your startup system, and then the startup system goes through a mesh of other services that have to kick in until you finally can come and run your application. No matter how much you try and make that faster, Systemd has really helped a lot with this piece right here. If you've compared init versus Systemd and watched the startup times, it's made it a lot better. We can take Y offline. That's kind of cool how they did it. But you compare that to a container, well, all of this is already running. And so the reason containers are kind of neat is because you just start the process and you don't have all these other things that have to happen. And they really brought this together. Docker is not the first company that was working on this. Containers came into Linux long before Docker really came around. What Docker did is they brought it together in a kind of more usable. They were the first ones to really make a really functional, usable way. Before that, you had to get the LXC toolkit, LXC toolkit. You kind of had to bodge your things together yourself, and so it was just a little bit more work. So a lot of people also get confused around all the different pieces of Docker. I'm going to kind of walk through what these are. The very bare metal piece, and actually Docker just renamed a lot of these things. If you guys have seen the newest, so it used to be the current stable is 1.13 of Docker. The next release is version 17. So with that came a whole lot of other changes. They went to a year.month.release system, which I'm a huge fan of. So the first part is Docker Engine, and that's what you're most familiar with. If you type Docker, you're using Docker Engine. If you do an install on your OS, apt-get or yum of Docker Engine, you're just getting this core piece. And what Docker Engine is it's that wrapping of the process, and it kind of helps bring together the storage. And I've got some diagrams that will help explain some of how Docker Engine works. Then you have another thing, which is build. And so when you create a container, what's really happening, the best way I can explain it is if you think of a stack of papers that are semi-transparent, and on the bottom stack you layer in maybe your base operating system, and then you want to make a change, and so you put another piece of paper on there and you write your change on that paper. You can still read through that and see the stuff on the bottom, but your change is now on a new sheet, and you keep adding these layers and layers and layers, and so that becomes your kind of image. And if you ever look at Docker and say do a Docker pull, and you see it's pulling down all these SHA things, those are each one of those is a different layer, and you're doing kind of this read through to make that total comprehensive image. The cool thing about that is it allows for a lot of inheritance and runtime states and I'll get to runtime states a little bit later. But what's happening during Docker build is it's that process of saying, I'm going to start with this image and I'm going to layer and layer and layer and layer. And if you've ever looked at a Docker file and it says run and run and run, every one of those runs is actually creating a new layer in your image. And so if you're looking to compress things, you can actually put it on one big fat ugly run stack, but then things get ugly and hard to maintain. So then you have the Docker registry. Internally to Docker on Docker Engine, everything stores on your local machine. And there's a couple different ways of storing. If anybody's ever run a Red Hat variant, the default way of running Docker is actually really unstable, and I don't recommend it. So you should go get thin pools, and if you want to talk to me offline, I can tell you about that, where it will use LVM to help with the layers, and it becomes much more stable. But all of that's local to the local machine. To then take that image and make it so you can use it on many different machines and share it with your buddies, you have to put it into a registry. And so what it does is it takes all the layers that are local and then it uploads them in kind of a conventional format to a registry. Have any of you created a login on hub.docker.com? That's their community registry. If you ever do a from, and then just like from Alpine, a common thing to pull from, that comes off hub.docker.com. That's the default where it pulls from. All that's the registry. Then you get into networking, and networking is where things get a little more confusing because Docker has added the ability to try and hide your containers and encapsulate them from the host, so they kind of become they feel a little bit more like a virtual machine. And in the modern concepts, there's also the overlay network that's kicked in to allow you to have multiple different hosts. I'll bring up a diagram on this to help you make it feel like they're all on one little private network, even if they're on separate physical machines. Some common systems to help with this is Weave and Calico, depending on if you're using Kubernetes or Docker in general, Swarm, stuff like that. Then you get into service grouping and clustering. So as soon as you want to have multiple nodes, more than just one as a cluster, you're going to start using systems like Docker Swarm or Kubernetes, and that's where they're really able to say, like with Docker Swarm, you can go out and create real easily, if you ever want to play with this, go out and create 3 or 4 virtual machines in whatever environment you're using, load up Docker Engine. It comes with Swarm nowadays by default, and just type Docker Swarm init, and it will initialize that first node in your cluster, and then it will give you the command to go type on all the other nodes, and they'll all come together into a cluster, and then you can do some Swarm stuff where you can say, run this container and make 3 replicas, and it will go ahead and kind of deal with keeping all that coherent and communicatable. Kubernetes is also another awesome way of doing that. If you've not heard of Kubernetes before, that's Google's way of doing it. They released that open source, and so that's Kubernetes descendancy comes from what Google runs inside their own compute cloud. The most painful part of containers you're going to find, though, is actually traffic routing, and that's taking so if you want to make a stack of containers, so you've got 5 containers and you're running your website off them, and this is getting into the ephemeral nature. You want things to be ephemeral. That means they're not really pinned down. And so you could have them come up on different ports and different IP addresses. But at the end of the day, someone's got to come in and talk to them, or you're really just kind of not connected, right? getting into those containers as they come and go and up and down and stuff, this is where most people start to lose their minds in the Docker world, because it's not as easy as people would like it to be. It's getting better. I say usually painful because there is hope. Docker 11.13 introduced ingress balancing, and I'm going to leave that for topics later as we get time. So if you have more questions around that, ask me about ingress balancing. And then delivery and pipelines, that's where we get into how do you deploy a new image of your container. So you have these containers, but if you're doing software development, your developers want to make a change, you've got to get that from whatever they're doing and through some sort of pipeline up into your production environment. And there's really, this is kind of the Wild West still. There's a ton of different systems out there, but very few of them really get into the concepts of pipelines. They'll get into saying, like most of them, your Herokus of the world. Nanobox is actually another system out there. They've got some local ties. They all have this concept that I'm a developer, I'm doing all my building on my local laptop, and now I'm ready for production. Push, and like deploy it out to production, and then you're there. And they really miss this concept that no, I actually, in any larger scale environment, you typically will have more than one environment. You'll have a dev and a test and a stage and maybe a QA and other things. How many people are running environments or are familiar with those sorts of things where you have environments that are going to be mixed up like that? More than one? Or how many of you, just by show of hands, have you played with, worked with, or seen it, worked in an environment where you've had more than just a developer straight to production? Anybody? Most kind of mixed here? Okay. That's where you're going to run into that. I actually have worked on a software product I've open sourced called Reflex Engine that also helps with that. Let's see here, Ephemeral Systems. To talk about what is an ephemeral system, I actually want to let's decompose what our applications are. Regardless of if you're inside of a container or a server or wherever you're at, you're going to actually have a couple elements to what composes your application. And these are, I think I have 4 written here. You have your stack, and that's going to include your operating system and anything that's required to run the application. Like, so if you're running a Ruby app, it would be the Ruby language has to be installed there. Everything that's up to the point where your code kicks in, because your code is going to be the actual, any modules that are needed by your language and all the code that kind of makes whatever it is you're doing work, right? Who's written, what languages? Just throw out some of your favorite languages. Let me get a feel for where people are at. Like I love, I don't know, it depends on the day. Python, I've done Ruby, I've done JavaScript, I've done any number of things. Anybody else? C? Python. Perl. I love, have you played with Perl 6? I wish that Go, I heard of Go, I wish they had not called it Perl. They should have named it something else, and like I think it has too much of a stigma, but Perl 6 is actually pretty slick. Anyway, more languages, what else? Lisp? Okay. So all of these are things you can run in the container, and you're gonna, so like the basic binary, Go, it would be a little different because you'll compile it up and then put it into the image that way. Elixir, we actually run Elixir out at Divi. And so it runs on Erlang, and so you can't actually make a binary and then just load that right into the container. And so that'll all be part of the stack up to a point, but your code is your application itself. Then you get into the configuration of how you run it, and this is where Ephemeral starts to actually really kick in, because it's too easy to just burn your configuration into your code. But if you think about that whole image stack idea, if you make that image stack generic, so that you can run that image and you can give it its identity at runtime. And so you can say, right now, you're an image that is for testing, and maybe you're running for this customer, but then you run that same image later on, you say, from that same base image, this is now a production image, and here's your other database that's over here. You should be able to introduce that config at runtime. And that becomes one of the key principles of being ephemeral. Who's seen the 12-factor manifesto? Is this a concept some of you might have heard of? Write that one down, 12factor.net. Read that, understand it. It came out of the group that built Heroku, but it really helped codify what ephemeral systems are and how they should run. And this can kind of cause some challenges. If anybody's run Java applications, like some of the more monolithic legacy applications, they've really matured to the point where they want to take care of things like their own logs. They want to rotate logs. They want to manage all their logs. Well, 12-factor says all logging goes to standard out. And so if you have one of these other apps, like I ran Postgres inside a container, that was a pain because Postgres wants to log everything out to syslog. And in a container, you have preferably you have one process per container, and one of that's not, you don't have syslog there, right? And so it becomes more painful. And then the last one is the data, and typically that does not go in the container. The data is going to be a database or something else, because the idea is that image, you should throw it away. Every time you have a new version, you throw away the old one. So why is this important? To me, I've been doing system configuration management for long enough that it really feels to me like we're finally getting close to the holy grail of system administration, because the biggest problem with managing systems, okay, how many people you use Chef, Puppet, Ansible, Salt, any of these above, right? None of them matter anymore when you have containers. You're done. Just stop it. And I actually have had the same conversation because Reflex Engine, I've met with various people, and I'm hoping to help out some of the Salt crew to bring some of these ephemeral concepts so that the conventional thing that often happens when people have CMS background, I mean, you've been spending years figuring out how to use Ansible or Salt or something else, and so you want to leverage that experience. And so I sat down, and here, can I go to the whiteboard? I'm not going to name any names, but I sat down with somebody at one of these organizations, and I said, we were talking around the challenge of running these config management systems with containers. And so if you have these container hosts, you have 3 Linux hosts, and you're running Docker Engine on these Linux hosts, and inside these hosts you might have a couple containers. Well, the first thing is let's go ahead and put an agent in every single container, and then my CMS system over here can manage them. Problem solved, right? That's missing the whole ephemeral point. And so then it's like, well, okay, what if we put our agent here, and then like there's some magic way it can reach in and manage the container. Okay, you're missing the boat again. Like there is no reason to have config management in containers, and that's what we're getting through here a little bit with these. And so some of the points here is that containers, really, we want, when we're running ephemerally, and containers help us with that. You can actually do ephemeral without containers. But the idea is that whatever you're doing is it's a disposable asset. So if you think about a factory, let's say that we're going to make a factory, and this factory is going to make airplanes. We're going to make small little Cessna-style airplanes, perhaps. And the way we're going to do this, we're going to get this big giant factory floor, and we're going to paint little squares on the floor, and we're going to make robots. And the robots are going to go around, and we're going to lay out the frame on every single spot in the floor. And so we start building up these airframes, and the robot, we say, okay, now it's time to go put the handle on the door. And so these robots run out to every single one and puts the handle on the door of every single one, and they come back and say, what next? And you say, okay, now go out and make sure the seats are right. And they go out and they do the seats, and you say, hey, go check and see if the color of the paint's right. And they're always going back and forth and back and forth. And you can see there's an inherent problem here because, I mean, as good as we try and make our CMS systems, there's so much entropy that can creep in on the side, it just doesn't, it's not a good model. And what ephemeral systems do is they really bring to the table the industrial revolution of the assembly line. That's really what's happening with ephemeral systems, is it really is like an assembly line. And so you create that image, you build that image, and it's version number 10. They actually do a SHA hash, and so it's really long, but let's just say 10. And then someone has a change you need to make. You got to change the color of this or that or whatever, and so you just build a new one, and that's version number 11. You throw number 10 away, now it's number 11. You relaunch, you're done. There's no CMS in any of this equation. And I know it's a really hard thing for people to let that go, but you know, there is roles for config management systems, but they're not in, it's in the stuff that's outside of the container. It's not going to be the stuff that helps with that. Yeah?
What about building your image with it? What are your thoughts on that?
I've wrestled with that. I don't really see much reason to, because the way Docker file works, it can be layered, because you can say from and from and from, and so you can say, you can make a base OS image. So say you have an OS image that's, I like to base off Alpine. So it's a 5 meg image base, and so you say from Alpine, and then you go ahead and do your base stuff, and you call that your base OS image. And then you have one group that wants to use Ruby, and so you make this Alpine-Ruby base OS, and so you say from my base OS, and then you bring in Ruby, and then maybe someone else needs to do, and so you can kind of create this little forking hierarchy of different images, and then you can tell the developers pull from whichever one they need. You get the same net effect, but it's all built into the cascading hierarchy. And the cool thing with all of that is that to make a change higher up in the hierarchy, you just go ahead and change the base OS image, and next time one of the lower images goes to pull, the layers will kick in. And so it makes it, I just haven't seen much reason to. I've seen people use templating and stuff on the Docker files, and it just, to me, I could be wrong. Tell me I'm an idiot. I'm fine with that. It just feels like, it feels like an anti-pattern. Is the best I can, as much as I've wrestled with it, I haven't been able to figure out a better way. So at the end of the day, the reason containers are cool is because they become this kind of Lego building block. The way that we used to build servers, if you think back on that factory analogy, you have the server crew, and they're over there with their config management, and they're building these factories that are popping out airplanes, and they do it their way, and then they shoot an airplane out, and it goes next door to the developer factory, and the developers go, wait, I actually don't want that engine, I need another engine. So they actually rip out the engine, they put in another one. And then for the next one, they're like, well, I really want like 7 seats on the plane instead of 2. And so they go through and change up that. And so all of a sudden they're making all these changes, and then a security patch comes along or something, and you go, hey, let's run and all of a sudden nothing works anymore because they changed it and your CMS doesn't match, and like it becomes a problem. And what's happening is that we've been building the shape of our servers to match the application. And while that's really cool for the application, there's just a lot of work that goes into keeping that current. What containers do is literally the reason they use the name container is because it's the same sort of thing that happened with the shipping industry. When they said, hey, ship whatever you want, it just has to fit in this box, it really changed how shipping works. And it's the same thing for applications and software delivery. If you say, I kind of don't care what you do, developer, but it needs to fit inside of this box, and as long as you're meeting certain maybe security things, do what you want, knock yourself out. You want to add in a library that changes your I18N, whatever, it gives that control back to the developers, and they really appreciate that. It really helps the whole process. I mentioned 12-factor app. This is really fundamental. If you want to do containers right, you need to understand the 12-factor app. I also have, on my blog, I've actually added a 13, 14, and 15, I think 16. I've added 4 factors. So.
I have a question about that.
Yeah.
I looked at some of the 12-factor stuff, and some of it is similar to like the reactive manifesto. Are you familiar with that?
I am not.
So it's a similar manifesto, but it's sort of more on the distributed computing, how to build distributed apps, and how you do event-driven systems and stuff like that. So you might want to look at it. I'd be interested to see how you.
What's it called?
The reactive manifesto.
Reactive.
Yeah.
Take a look at it.
Reactive systems are scalable, distributed.
Well, and that's why I say this is kind of holy grail, because this is stuff that, as an industry, we have been struggling with this for a very long time. This isn't like Docker came up with some magical concept. I think that this has been culminating at large for a very long time, so it doesn't surprise me to see other people that have come up with that sort of thing. I added in the extra 4 factors I was talking about, and these come together to bring the ephemeral immutable app. Mostly what I'm talking about in those last 4 factors are around security and compliance, because I've done a lot of work with compliance. I didn't even mention some of the stuff I did. I built a data center out at Hill that allowed us to bring the F-35 to Utah. I had a lot of fun with some of those security things. So,
Are you going to talk about those?
I can. Yeah, we'll have to turn that camera off though. Just kidding. So just to decompose visually some of the Docker engine, what you've got is you're going to have your host that's running, you have the Docker engine system. To get a container, and this is the thing that most people miss, the container is actually the running state of all these other things. So when you bring your bridge network or your host network, and I'll explain those in a sec, and you bring it together with these layers of storage, and you now have your process, like those things come together, and that running state is the container. It's not a container when it's just an image on disk. That's just your disk image. And that can be a challenge for some people to wrap their heads around sometimes. So now we have this host over here. We're doing our container stuff here. Now we bring in the registry. This is off host. That's that idea of taking those images and separating them out. And this is where it starts to get fun, is when you want to cluster it. So let's talk a little bit about networking now. Your host network is anything talking to this bare metal, whatever is your outside interfacing network. Then Docker brings in, your basic engine brings in the concept of a bridge network. And so if you're just running on one machine, run your laptop, whatever it is, you fire up a container, and it's going to run inside the bridge network. And so it's going to be a different, it just picks a network block. Hopefully it doesn't collide with anything. It tries not to. And then it runs it on that, and you have to go through and say, no, publish my ports. And so if your app wants to grab 10 ports, and you want the world to see it from this host network, you have to publish them from here into the host network. Has anybody ever seen that publish? You'll see, like, if your service wants to run on port 3000, you'll see some sort of publish or port definition that says 3000 and maybe a colon and 3000. Have you guys seen that sort of thing before? What that's doing is it's saying, take it from the bridge network and bring it out to the host network. If you don't do that, you're going to be out here trying to talk to it, and you're never going to see it because it's encapsulated that network. Where things break down, though, is say that this bridge network is running on 10.0.0, and this bridge network's running on 10.0.0, and this one's running on 10.0.0. You have a container start up here, and it gets .1, and then this container gets .1, and this one gets .1, but you want them to talk to each other without having to go all the way out, over and back in. That's where these overlay networks kick in. That's what a lot of people have wanted. And so what they've brought to the table with Swarm is they do an overlay network where it's like a bridge network, but it's shared across all the hosts. So we have a service. Has anybody ever run Erlang before? Heard of Erlang, Elixir? So it can do clustering itself. All you got to do is tell it its peers, and it will cross-communicate, and it does its own chatter and allows you to do really fun RPC type stuff. But I didn't want to have it go out the NAT and back in, and I didn't want to publish those RPC ports to the rest of the world. They really just need to stay internal. And so when these apps start up, we give it the peer addresses on the overlay network, and then we only publish the service address that load balancing cares about. And so then they can, all the cross chatter, all the cross communications happens over that overlay network. But then the load balancing, it comes in and hits whichever node, and all that works that way. So the overlay network is really nice. You can get that with Docker Swarm. Kubernetes has a similar one. The other thing that some of these are starting to do now, trying to think if, so Calico brings this in. I don't know if Docker Data Center does this one or not. So if you're running Kubernetes, you can configure it so that every container gets a unique IP address, even on a host level, so you can actually, and this is not a conventional configuration, so maybe I shouldn't even talk about it, but there's ways, I mean, it makes it feel more like a virtual machine. I don't know if it's the right way of doing it or not. Because this is an open source product, you can twist and convolute this thing in almost any direction you want. Before I jump on to the next, any thoughts up to this point? I'm kind of just hammering through these things. What do you guys think about the ephemeral concept of throw it away? And it can be a challenge because, especially in the security world, if you have an image that's running, who's heard of Amazon's serverless, right? That's running in containers. I have challenges with serverless myself on the security side. So if you're running a container and someone hacks into it, you got this container right here, and they manage to get through all the traffic, and they hack into it, and they go around and start monkeying with files on that image, and you deploy a new version of the container. Say this was image A, you put out a new release, it's image B now. Well, that new image B doesn't have any of the stuff that were vulnerable because you patched it, but you might want to go back and do some forensics on image A, and it's kind of tough for some people to be like, well, it's ephemeral, it's gone. There are things you can do to make sure they don't get deleted. but mostly it's going to be logging off the container, because as you get into more of the clustered systems, they really try hard to clean them up, because if you leave these things laying around, then your disk fills up. So that can be a challenge for some people, that kind of ephemeral state. If you have an application that likes to write to disk, I ran an ERP system at another place I worked. And if you want to do batch processing with ERPs, these guys are still stuck 20 years in the past. And so they want to be able to, pull in a whole bunch of files and process on them locally, and then have this kind of metadata sitting on local disk. Well, that doesn't work too well if every time you restart it, like it's gone, right? That's not a good thing. So there's certainly some challenges. Anybody have any other thoughts that could be challenges around ephemeral if you've tried getting into this space before? I've seen a couple head shakes. So I have just my own experiences. Click. There we go. As I've seen and played myself with different container systems, there are some common mistakes that are out there. Number one is not understanding your pipeline, or I should say, sorry, the first one on the list, but counting down from number 5. This is most commonly seen because a development team says, hey, we're going to build this new application, and they start building another laptop, and they don't think about what other requirements might exist. They don't think about having a testing environment and a production environment and a pre-stage. All these things, like they're just like, I'm building and I'm deploying, I'm building and I'm deploying, and the world is good until they actually have to go live, and all of a sudden they realize they have all these other things that they've forgotten about. But they're in containers, and it's someone else's problem now. They're just developers. And so that can become a huge, huge roadblock, especially in the 11th hour when you've got executives saying, hey, the app looks great when they demo it to me. Why can't we get it live in production? And you're talking about, but I have to have these different lanes because of whatever, maybe it's regulatory or whatever it is. So getting ahead of the pipeline, having a staging and production, whatever environments your environment needs, make sure that's figured out earlier than later. Configuration management. Where do I put my configuration? I'm actually going to jump to another slide to get into that in more detail. But at a high level, a lot of people have kind of given up in containers, and they just stuff configs into your env, your environment variables. And that's dangerous, that's difficult, it gets out of control, it's hard to manage. Which leads us to point number 3, is not appropriately handling secrets. So what people will do is they'll put their passwords to systems in environment variables. And they're like, well, everybody else is doing it, so it must be okay, right? Come on. Consensus, right? And then not understanding the idiomatic pattern of containers. This is probably one of the bigger challenges people will run into. The idiomatic pattern is, and so idiomatic is basically the right, kind of the, I don't want to say right way, because there's never a right way, right? The idiomatic pattern is, it's going to be kind of the middle of the road where you're going to have the least resistance and the most success. And part of that idiomatic pattern is to say, I'm going to have one process per container. None of these are hard rules. You can break them. You can have more than one process per container. But if you want to put init into your container, you got to start wondering, am I doing this right? Because you don't really need it. Now, that being said, there's a really cool tool you could run called minit, which is a little mini init. I've had to use that with the postfix thing, but typically you want one process or so per container. Another part of the idiomatic pattern is this ephemeral state. One of the biggest challenges I have with the Heroku type world. Who's seen Heroku? Do you guys much exposure to that? Not really? Heroku is very developer centric, so it kind of doesn't surprise me with the Linux crowd we got here. What it is it goes to the developer and says, we don't need system administrators anymore, just run these commands and we'll take care of all the back end for you. And that's cool, but at the end of the day, it becomes a little non-idiomatic because you run into problems with pipelining, and you run into problems because the developer invariably wants to try to do something in that container that they don't understand, and they get problems with networking, and it's really great for prototyping in my experience, and you run into challenges when you try and run it in production. So one process per container is right in the middle of the idiomatic, and thin. Keep it as thin as you can. And so I started on a project, and we did a build of this container running Node. And if you've ever run Node JavaScript, its whole claim to fame is it's supposed to be thin and tiny and light. The application, so who's run Node before? npm install. So you run an npm install, it pulls in all these other dependencies. After running npm install, this application was 1.2 gigabytes. Okay? And then on top of that, we had all of the rest of the application that came with that and all the side dependencies of all the other packages they wanted. And so the image they ended up with was gigantic. And part of the idiomatic pattern of containers is you want to be as thin and tiny as possible. And so there's been a whole new resurgence in these lightweight operating systems. Instead of running Ubuntu or Debian or CentOS, you should look at the Alpine type worlds and stuff like that, because they're focusing in on this use case of making the thin, lightweight, tiny images. The Alpine base image is 5 megabytes for the whole base image. You compare that to these others and you're going to be many times the size of that. In fact, I meant to go backwards and not drop them all. Talking to that point, I took one application that was a different, not the Node one, but a different application, and its image that was built came in a little bit over 1 gig. And all that I did was rebuild that same application in Alpine, using a container in Alpine, and it came in at about 450 meg, just by switching from Debian to Alpine. And so the reason this is important is because it comes down to delivery, because when you're doing your pipeline and you're pushing a change from dev through stage to prod, whatever, you want that to go really fast. And if every single server has to copy down 2 gigs of data, it's just not a good idea. Docker helps with that because it only copies the layers that have changed. So we go back to that paper layering model. If the base 3 layers haven't changed, it doesn't copy them again. It only copies the upper ones. So it's not like a horrible problem, but it's still a problem. Keep it thin. And then last one, and this is what I see most people do, is they say, we have this new application, we're going to use Docker, and they try to do every single thing that's possible all at the same time. And Docker, like when you hit that remember the 7 things or so that Docker, like all the different parts of Docker I was talking about, and at the bottom I talked towards networking and pipelines. That's usually where people start to fly off the rails. Docker Data Center has a great Amazon, if you have an Amazon account, you can do a turnkey spin up and demo it, pilot it for free, take it for a spin, play with it, see what you think of it. Tectonic, they have an awesome one. I think it's a little more polished today than Docker's. Does the same thing, fires up a Kubernetes stack. There's also a Kube AWS script you can run that generates a CloudFormation and spins it up in Amazon. So there's really easy ways to test out some of these more complex systems. But what happens when you get into these is all of a sudden you have all these other dependencies that are kicking in because of traffic management. And how do you route your data? And all of a sudden you want to bring maybe a web application firewall and put it in front of things. And you want to integrate it with your single sign-on. And like all of a sudden the complexity just compounds. And so my suggestion is, if you really want to get your head into Docker, start small. Don't worry about Kubernetes. Don't worry about data center. Don't worry about all these other things. Build your images just in Docker Engine. Figure out that. Play with the project that just needs one thing. I think one of the first things I did that really helped me get my head into Docker is I actually took an old email server I had running postfix, and I bodgered and shimmed and hacked on that thing, and I got it running in a container. Find something like that and just get it to run in a container. That'll help you to figure out kind of all the different pieces. Once you've hit that, I would say the next thing to try is play with Swarm a little bit, Docker Swarm. It will help you get into the concepts of services and some of these other things. Step into it slowly, rather than going in and trying to take on the whole world all at once, because most times you get, what I've seen is that you have analysis paralysis kick in, where there's so many options on the table, and this is changing. I've been doing these things a long time. I can honestly say I've never seen this technology come out so rapidly, so fast, with just massive improvements as it is right now in the container industry. This is a rocket ship right now. And every month something new comes out that is just amazingly cool and makes things that much easier. So relax, recognize that you're not going to understand it all. pick a few pieces, come to understand those pieces, and know that around you more cool stuff's going to keep happening, and just let it go, and that's okay. So one of the challenges that everybody's still wrestling with in containers is configuration management. We talked about ephemeral. The problem is, where do you put your configurations? So after I've been rambling now for a few minutes, let me just ask you guys, if you remember the stack, we have an image and it's going to have our stack, which is our operating system and all the, maybe it's Ruby or something. Then we're going to have our code, and it's going to be a layer on top of that. And this is going to make up an image, and we're now going to launch this image. How would you recommend you introduce a database configuration to that image? What thoughts? Because I've mentioned environment variables. Does anybody else have any thoughts of other ways you might be able to get stuff into that container?
Is that before the container launches or after the container launches?
Whatever. Hack on it.
Command line flags.
Command line flags, yeah. You can do some. You can actually pass. They become environment variables, actually, which is the problem. You can bring volumes into a container, so you can put your configuration on an external volume, and you can tell the container to run, and you can then bring that volume into the container, and then all of a sudden all its config's there. That breaks down in a cluster, unless maybe it's on NFS, but now you're sharing like your secrets on NFS, that kind of little wonky. I think maybe what you were talking about, if it's before you run the container, you can build a different image for each environment, but you're kind of missing the whole factory assembly line model.
You have a service that you go out and retrieve your configuration from, so you've got to have some sort of bootstrap.
That's really where the industry is heading. So what's gone on is you have HashiCorp has a product called Vault. You've got different services out there that have these places to store secrets. Docker now has introduced Docker secrets, and so you can actually define a secret vault, and then it will bring it into the container through a file system call. But you still, what's happening is...
But you still have to have secrets. If you got to access the service, you got to have them.
You got to have another way to get into it,
So
right?
how do you bootstrap your credentials?
This is part of the challenge. And this is one of the things I've been dealing with. So one of the reasons I wrote Reflex Engine was to try and wrap my head around this and deal with some of these things. So the image is one place you can burn it. We talked about that. But then you don't want secrets, because that gets pushed out to that repository, and they're burned into your image, and now you can only run that image in like stage or whatever it was you built it to. The environment, you can get to the root level of the environment pretty easily, and then you can read every container's secrets on that, because they're just stored in environment variables. Environment variables are readable by any other process on the stack. They're not the same as variable space. So environment variables are a really dangerous place to put stuff. Did you have a thought?
Couldn't you put a public key on there that could access?
Mm-hmm. That can reach out and grab something. And that's getting into what's the next one. This is kind of where everybody's heading. So the kind of idiomatic way up until the last year or so has been, when you build a container, you define an entry point. And it says, like if I'm running a Node app, my entry point would be node index.js. And so when I run that container, that's what it runs. That's the one process, is node, and it runs on index.js. Well, now people are putting in kind of a wrapper that basically says, I'm going to go and I'm going to grab scripts when I launch. I'm going to go out and I'm going to grab secrets, either through the secrets vault, or I'm going to go to HashiCorp, or Reflex does the same thing. The Reflex Engine, it has this launch script. And that script will go out and it will prep the environment for the application at runtime, and then it runs the application. And so there's kind of the shim that's going in right before. And it really is not that big a deal.
So does Docker support trusted execution environments?
That's not, yeah, so the trusted execution environments, are you talking like with the VMware and or the VM in general?
Intel has one, and then there's an ARM one.
Yeah, so the CPU level extensions, what those are doing is they are partitioning. So if you're running at a virtual machine level, and this is a really important semantic, containers are not virtual machines. If you're running a virtual machine and you're sharing that hardware with other hosts, these trusted extensions allow the hypervisor that's driving all these I'm going to have nomenclature clash here, that are driving all these virtual machines, it allows it to partition the memory at the hardware level and say, this memory is allocated and no one else can read or write into it. It helps it separate and segregate in a more safe manner. so that you can have that. And the containers, they're running in the Linux kernel. You have one Linux kernel. That's the other thing that makes people sad when you really get down to it is someone's like, well, I'm running containers in my Mac, or I'm running containers in Windows. Actually, you're running containers in Linux. It doesn't matter what host you think you're running it on, they're booting a virtual machine and then they're running containers because it's a Linux kernel extension type thing. Solaris would be the only other environment that potentially could handle this, but unfortunately Oracle has tanked that.
Support containers directly, it's allowed to boot to it, Linux.
Yeah, because, I mean, if I honestly haven't looked into FreeBSD for a very long time. When I was doing a lot of FreeBSD work, there was the ability to change the binary stack that it would execute so it could actually run Linux binaries. I don't know where they're at nowadays with things, but the problem with that is at the end of the day, the container, there is some things that are happening with the container where it's partitioning memory, not necessarily in a trusted execution way, but it is partitioning memory, and you can say this container can use no more than 1 gig of RAM. It can use, and it will do shares, so you can say, I have 10 containers on this host, and I'm going to let each of them have 5 shares. And then it does a ratio-based allocation of CPU so that no one container could take over the others, and you can do things like that. And yeah, no, it's fine. And then the fourth one on configurations is you can actually have your application just read directly. So if you have this remote store where you've got secrets stored, you could have your app just directly read from that and pull it in. That is also an option. Anyway, I think that is actually it on the stuff I've got prepped. I could talk on this stuff forever, so.
So I have a question, because you didn't answer my question. If you want to have a remote configuration store that you want to be protected, then anything accessing that's gotta authenticate with some sort of credential. But if you put that credential in your container, then it's not secure anymore.
Yeah.
So how do you bootstrap that? Do you have to have somebody manually log in and provide that credential before it can bootstrap?
So what I did with Reflex Engine, have you heard of the term ABAC? Attribute-based access control. Anybody, ABAC? This is a new term. Go out and look it up. Internet of Things, you've heard of that? ABAC has come around, and it's still a forming, this is on the bleeding edge of bleeding edge type concepts, but ABAC is the concept that rather than role-based access control, it's an attribute-based access control. And the idea is that really roles are just one attribute, and there's many attributes that actually exist, and if you start to bring a combination of attributes together, that makes it stronger. Multi-factor authentication is just a form of ABAC. You're now bringing 2 factors into one, and that makes it stronger. The best example to really explain ABAC is going to be if you're writing a healthcare system and you're doing or patient records, and you then set it up so you have a nurse that has the role of nurse, and they have a username, they have a password, they might even have 2-factor authentication. Whether they're standing next to the patient, they're at their desk on their floor, or they're at home, they can access the records they're authorized to access because they have multi-factor authentication, whatnot, right? Well, ABAC says, no, there's more attributes here. We can actually put an RFID tag on these patients' wrists, and then they can sit at the computer and they can have a reader that says they can only pull up this data if they can then scan that patient, if they're close enough in proximity to that patient for that tag to kick off, and they have the other attributes, and all of those together in combination then open up those patients' records. And so that combination of attributes is really what makes ABAC work really well. And so what I did with Reflex Engine is all of the secrets, so all of the other systems I bumped into up to now, they're a key value store, and you run into this conundrum you've got. If you look at, who's used SQL before? Select whatever, right? If you have access to a table, you've kind of got access to every row in the table at the same time. With Reflex Engine, you can go through and you describe policies, and it just uses a logic of this and that, or this and that. And what it does is you can add an attribute that says, here's an API key that I'm going to give my container in production. And then in addition to that, I'm also going to have this attribute that says it's coming from a set of network block that I trust. you could add an attribute that says it also has to be using an SSL certificate, that maybe it gets using the Docker secrets, because Docker, you can preload certificates, and so it comes in and says, here's a client-side certificate. So like these three things together, now there's some power there. And so you can just go ahead and put that API key in the environment variable, and if someone steals it and tries to hit you from the internet, it kind of doesn't matter.
You have to have something private then, like a network block that you only have control over. So
Yeah, it's just the attributes.
If they hack your ISP, then your security fails, right?
Right. Security.
So it's not hard crypto. It's not like having a true private key. It's right place, right time. Makes it harder for people, but it's not.
And you can't. I think my attitude on security is that prevention is more important. I said that wrong. Detection is more important than prevention. And I do have a story I can tell you from base. So when we were building this data center, we had a whole bunch of different requirements we had to build to. It was really a fun project, getting through all the multi-layer security and all these different things. And I was fascinated because one of the requirements was we had this door, and they brought in this special frame, and they poured concrete in the frame of the door, and they brought in a door that can handle a huge bullet. They had these really fun spin locks that are digital, and the combinations, and this really cool technology around this door. And then we have sheetrock walls right next to it. And as I was talking to people about this, it really kind of clicked, and this really helped concrete for me some concepts around detection over prevention. And the general gist is, yeah, if someone's determined to get into that room, they're going to get in. But if you have a standard door, you could actually, and this is in a business office, right? And so someone theoretically could go hammer down that door, close it, and other people may not even notice it. And they could have time in there to do whatever they needed. Before it was really detected, that might have happened. But if someone's going to rip a hole in the wall, they're not going to go in there and mud it up and paint it and fix it before someone notices. It's a lot more evident that that has happened. And that's really what security is about, is it's about detection over prevention. In fact, there's a statistics out there. I'll quiz everybody. What is the average time to detect a breach in the industry? Average. So this is considering the high and the low. What is the average time in the industry to detect a breach of any type? Whether it's someone just infiltrated, exfiltrated, just got access to something they shouldn't have. What is the average time? Any speculation?
Longer than a year.
You think? 1 or 2 years? Longer than a year? What else?
Average has got to be less than that.
You think it's less than that? What do you think?
I guess 2 months.
2 months? Anybody else?
I read something 6 months more.
6 months? The average time is 1.5 years to detect a breach. And that's all because we suck at detection. Honestly, it's really hard to detect right. And we got to get better at that.
That would have to include those that were never detected, because, I mean...
Well, some of these breaches, they'll discover them, and they'll figure out that...
Target breach, they were there for 18 months.
Yeah, they figure out these things have been there for a very long time by the time they're finally tripped over. And that's the problem.
The guy calls you on the phone and says, we found your data on the internet.
Yeah.
No, that can't be my data. Where's the proof?
Yeah, yep. I think, yeah, I could talk security for a long time, but there's, yeah.
What roles do you see config management taking? If you're not going to use it to make your containers or run your containers, what roles do you see it taking?
You're going to have, there's always going to be stuff that doesn't necessarily fit the container mold. Yeah.
Would you say like standing up the environments would still be...
Standing up the environment, so it depends on if you're running in Amazon, so I was pondering that. If you're running in Amazon, they've already got some stuff for that, so it's kind of not as big a deal. But if you're running in a hosted environment, most definitely getting those bare metal, from bare metal up to a running clusterable system is something you use config management for. You're going to have your traffic management. If you're running whatever traffic management solution you're running, managing and building up these pieces. Like running into a container is not always going to be the most network efficient, and it's not going to be the most storage efficient. And so you may not want to run databases in a container, stuff like that. I mean, you can, it's just a lot of work. But
What tools have you seen for the pipelining stuff? Running Jenkins in test dev environments, spinning up containers and running tests against them, and then that triggers a new deploy, or
so
that a little bit?
I've played with a lot of different ones. I played with Travis, with CodeShip, with CircleCI, with Jenkins, and there's others out there that I haven't played with, but I played with those four. Building and deploying are two different use cases. And anytime I personally, or I've seen anybody try to bring together those into one use case, that's where your pathway is fraught with peril. They really are two different use cases. And so spend time, knock yourself out on making an amazing build test system. Then once you got it built, have another system that can maybe be the same, but often the two tools don't work very well. Like Travis, Circle, and CodeShip, these sort of things, they actually don't ship very well. They don't do the pipelining very well. Jenkins has a newer version of pipelining that's actually pretty cool if you haven't seen Blue Ocean. That's kind of where I keep falling back to. Jenkins is like the tool that you love to hate and hate to love. I mean, it does a good job, and it's painful and it's awful, but it does a good job. So I usually fall back to that one. I've been wanting to use Spinnaker. It's another tool out there that can do some stuff like that. There are a couple of the tools that really do delivery really well, but they haven't really caught up with containers as much. One of the things that you're going to run into with containers is that most of the deployment of containers, like Swarm, for instance, has all this great logic around wait so many seconds after that container started and then start another one and do da-da-da-da-da. The one piece they're missing, and this is one of those, I said I have 4 extra factors. One of those factors is that you should actually test the application is running. And so after the container fires up, you need to have some way of actually querying that application and verifying it's functional before you move on to the next one.
So what do you do about that? Are you writing custom schedulers for that, or?
So what I've done for that is I actually have a kind of convention that I ask my developers to follow for doing tests, a standard way of calling tests, and that returns the version number of the build that container happens to be. So I can query the container. I can go ahead and say, what are my containers? Here's my 6 containers. And I can go 1, 2, 3, 4, 5, 6, and I can hit each one, and I can say, of these 6, these 3 are on the right version, but these 3 aren't. And so then I can go ahead and wait, and the stacks will go ahead and keep rotating itself along. And once all of them are up to the right version, then I can go ahead and green light the next stage. And I've just got automation that takes care of that. Yeah.
One thing I've found with testing is you need to actually query the app to get the database.
Mm-hmm.
If you only know the app's working, but
Yep.
all the credentials to the database.
This is probably the biggest challenge I've found with many of the developers is getting the correct testing. I like to do a health check endpoint, and the spec that I give the developers is name it this certain way and return HTTP 204, which is a OK with no content. And then if I give you an argument of like query arg of a certain way, then go ahead and send me a JSON object, so a 200 OK with a JSON object that then gives me some payload information. But either way, if I query you, you need to have checked those things. Don't just say, OK, I'm here, hello. It's not a ping echo type thing. It should be, I verified all my database pool is good. I verified whatever my buffers are, whatever it is you need to verify, they definitely should make sure all of that's good before returning that OK, for sure. Other thoughts, questions? Cool. Well, have fun with containers. I enjoy them. Feel free to reach out and talk to me, ask me questions. I'm okay with it. Hook up with me on whatever, LinkedIn, Twitter. I actually only started Twitter a few months ago. I'm kind of a latecomer to that. I don't share well.
I actually have a question. Are you familiar with the concept of zero trust computing?
I have heard that concept. I can't place it though.
It's basically using distributed consensus and blockchain stuff to do some of the security parts of access control and
Yeah. That could be,
Majority of them.
I'll have to look into that, because I know one of the things Docker Data Center is bringing to the table is they have signed images. And I don't know if they've done it right, but I hope they have. I want them to be able to do, it might be related to what you're talking about. So you have the ability to, your BIOS can have keys that then only are authorized to boot certain signed images, and then those images can only run certain signed and certain signed and certain signed on down the chain. I don't know if that's related to what you're talking about.
Because that's a chain, this would be, in order to get access control, you'd have to submit a request to a pool, and everyone in the pool has to authorize it. Which means that if someone hacks one of the pool members, right, they can't change the authorization. They'd have to hack
All of them, yeah. Cool.
So you could do secret sharing where each of the pool members only stores part of the secret.
Yeah.
So if you requested a secret, then you'd have to get a bit from every one of the pool members. And so if they have one of them, they don't have the whole secret.
Sounds cool. We'll have to talk. Anything else? All right. Thanks, everybody.